welcome back. We now have our first masterclass of the day. We are joined by Jen and Lauren from BAE Systems, and they are going to be doing a workshop and telling us all about emojis and how they support diversity. So I will hand over to you both.
Thanks, Becky. Just all the tech ready. Okay, good to go. So good morning, everyone. First of all, thanks to Digital Her for inviting us along today. And thanks to you guys for joining us. We're just going to do a quick intro of ourselves before we get started on the presentation. So as Becky said, hi, I'm Lauren. I work for BAE Applied Intelligence and have done so for almost 6 months now, but I've worked in the IT industry for about 6 years. I actually studied physics at university. Straight after I worked as a geophysicist in the oil and gas industry, but I decided this wasn't really for me. Made the choice to retrain and got accepted onto a solutions and software development grad scheme. And that was my entrance into IT. So although not the most conventional route, you might expect perhaps a background in computer science, for example, we do see some more pure science degrees being a relatively common path into a career in IT. In my current role, I am a business analyst and I work in cybersecurity, which is a really exciting and fulfilling area to be in right now. Actually quite an up and coming one in the city of Manchester, so it's a good one to look into. Being a business analyst means I'm less hands-on with the computer stuff than a coder like Jen, who's going to introduce herself in a second. And in simple terms, I sort of focus my time on ensuring that the team are clear about what the customers have asked them to make the computers do. And it's a really good career and I really enjoy it. Over to Jen.
Morning, my name's Jen. Thanks for having us again. Lauren and I are really excited to be here today, so thank you. I am a software engineer, which means that I write lines of code every day. There are lots of different types of software engineer. I'm a particular kind of software engineer called a web developer, which means that I create websites out of code. So those lines of code that I write on the screen, I click a button at the end and they turn into a website like we'd see, like we're used to seeing every day online. I didn't start off as a techie person at all. I did history, English literature, French at school. I did history at university. I had a completely different job for years before I became a software engineer. But a couple of years ago, I decided that I wanted to be part of the digital world. It looked really cool. So I taught myself to code in my spare time. And then I did a part-time course in the evenings with a coding school called Manchester Codes, alongside being a full-time mum. So I retrained as a software engineer and now it's my full-time job and I absolutely love it. So I'll hand back over to Lauren and she's going to talk to you about emojis and we will take you through our presentation today.
Yeah, thanks, Jen. So I think just before we crack on, there are a few questions and exercises in the presentation. If you want to send in answers, please use the chat function. Someone will be monitoring it and can feed back the answers to us, but we also have some websites to visit as well. So if you have a phone or a laptop handy, go ahead and use it. There's a QR code you can scan to get onto them as well. But I think this is being recorded, so you can always go back and revisit some of them at a later time. One more thing as well, if you have any general questions while we're going through the presentation about career or BAE, anything, just add them to the chat and we'll have time to answer them at the end and we can collate them. And there's time to ask questions as well at the end. So if you think of any, do ask them, please. Great, so I'm just going to share my screen, get started. We good? We've got a presentation up. Fab. So today we're going to talk about how emojis like these ones work and how they support diversity. And I know this sounds like a bit of a weird connection to make, but at the end of the day, people are at the heart of technology and it should really contribute to having a positive impact on our lives. If we can get computers to help break down barriers and support equality, even in a small way, then we really should do that, shouldn't we? It seems like such an obvious question and an obvious answer. So, computers. Let's have a quick think. What are some things computers are bad at? What I've got, oh, sorry, it's going a bit wobbly. Emotions. So computers don't care if you're happy or if you're angry or if you're sad. It's just going to treat you the same. It has no idea you're feeling any of those feelings. Uncertainty. So computers do not deal very well with unclear data at all. It needs to be black and white for it to be understood. And social interaction, human language, similar things. So you can't treat computers like you treat people. You can't have a conversation with a computer in the same way that you would a human. But computers are good at some things as well. I've covered the bad things. What are they good at? This is what I've got. Numbers, that's pretty much it. We know computers are good at numbers, bad at most other things. I'm sure there's more on this list that we could add. So everything comes down to numbers. When we want to use words on a computer, we need to somehow turn that into a number. So that's where we're going to have a go. We're going to start with letters first, and then we can sort of work up from words, and then obviously we would expand that. But right now, let's have a quick look at letters. So this is probably the simplest way that we can encode letters. So that's what we call it, encoding, when we turn letters into numbers. 1 to 26, alphabetical, A to Z. So this works, and we can give it a go. If I put my name on the screen, Lauren, L-A-U-R-E-N, you can have a go yourselves. You can add it into the chat to try and encode my name as numbers. So if I give you a quick start off, so L obviously corresponds to 12. And if we go through the rest, feel free to add it into the chat. I'll give you a little bit of time to get your eye in. I think Jen might be monitoring, but I'll go through it just for the sake of time. You can do the exercise yourself. So I'll run through it. We've got 12, 1, 21, 18, 5, and 14. So L is 12, A is 1, U 21, R 18, E is 5, and N is 14. So we've encoded something. We have converted letters to numbers. It's that simple. So now we're going to try and decode something. So decode is just the other way around. So numbers to letters. So if I put these up, I'll give you a little bit of time. If you're doing it in your own time, I'll give you the answer. Okay. We've got E-M-P-O-W-E-R, empower. And that's basically a simple overview of what we call in computer world a character encoding, a way of turning letters into numbers and vice versa. So this is our encoding scheme that we just used. So it feels like there's stuff missing. We send more to a computer than just these uppercase letters, don't we? So what do you think could be missing? If we said lowercase letters, then well done. That's one thing that's missing. And again, if you thought about punctuation, spaces, and numbers, again, well done, because that's obviously missing. We send these to the computer all the time. So here we've got a slightly expanded character encoding from the one that we used for the exercise in the previous slide.
Okay, thanks, Lauren. So we've just come up with one way of allocating a letter to a number, right? We took A, we gave it a 1, B was 2, etc. So it worked okay, didn't it? We could write a code out of that sequence we came up with. But back in the 1960s, people were inventing different ways of allocating these numbers, and they weren't talking to each other. So in one part of the world, they might decide that the letter A is 1, but in another place, they might decide that the letter A is 13 or 25 or something completely different. So that was fine before the internet was invented, but when computers started to be connected to each other, this became a problem, and computers were getting confused and they didn't know what letter to show at all. So ASCII was invented. So ASCII. Lauren, if you can click the next button for me. Thank you. So we can see that ASCII stands for the American Standard Code for Information Interchange. We kind of don't really need to remember that, but it's useful to know what it means. So the ASCII standard attempted to make that the same across the world, so that A was always the same number and Z was always the same number. It really caught on, and it's what's still used today by all computers across the world. So remember, we had 1 for capital A. If we take a look now at the standard ASCII chart, here we go, it's just appeared on your screens, that blue bit there. And we can find a capital A, so let's have a look. There we go, we can see it in the middle at the top. So we can see that according to ASCII, they've decided it's 65. So now every computer around the world, and by computer it can be anything. So it can be your smartphone, iPad, a wearable like a Fitbit or an Apple Watch, even your Alexa, it knows that 65 means capital A. Handy, huh? So the eagle-eyed amongst you will notice that this chart only starts at 32. You're probably thinking, what's 0 to 31? Well, you might be. We'll have a quick look at what's assigned to 0 to 31. Lauren, if you can show those for me, thank you. So they're called control characters. We really don't need to spend too much time on these, but basically they allow computers to send other information or instructions to each other than letters and symbols or numbers. So way back in the 1960s and 70s, when all this was being invented, some of these things were much more important than they are now. So let's have a look at one example. So number 7, you can see a few down on the left-hand side. Bell, that makes the computer make a ding sound. So I guess that must have been important when they were inventing this in the 1970s. Who knows? Cool. So that's ASCII in a nutshell. Let's move on to something else. So hexadecimal. I'm briefly going to talk about this with you. It's a good word, right? It sounds really techie. I mentioned I've only been a software engineer for a year or so. And since I've started to learn all this stuff, I've found that if I mention a word like this around my friends and family, they look really impressed. It's quite cool. So what is hexadecimal? Let's break it down. So we know from school, right, that hex means 6, as in hexagon, and dec or decimal means 10. So we add 6 and 10 and we get 16. So that's it. Hexadecimal means 16, just like hexagonal means 6 or octagonal means 8. Hexadecimal means 16. Now, when we were looking at ASCII just now, all of the codes were made up of numbers. Lauren, please can you show the first thing on this slide? Brilliant, thank you. So they were all made up of numbers, just using the digits 0 to 9. Simple. But it turns out that computers also let us use some numbers to make up the codes too. So if we were just using these digits 0 to 9, eventually we'd run out of possible combinations. And I know it seems like there must be, hundreds and thousands of them, and there are, but eventually, believe me, they run out. So we need more than that. So we add some letters to the end of these numbers. So can you see there? We've added A, B, C, D, E, F to the end. Now, if we add in those 6 letters, suddenly the number of combinations we can use is much, much bigger. We can use 0 to 9, A to F to make up our code. So we're going to have a look at a few examples of what I'm talking about. Here we go. So what you're looking at now at the bottom of the screen, the bit that says 2A and FF3E9 and what looks like bad food, those are hex codes, hexadecimal codes, but we call them hex codes for short. So you can see that we've just taken any combination of numbers and letters and we've added them together to make a unique code. Now, one more thing, when we're talking about hex codes, we usually put a 0x in front of them. There you go. So it looks a little odd at first to get used to, but the easiest way I find to think about it is just to basically ignore the 0x. All it says is that, hey, there's a hex code coming after this 0x. So we know then that we can ignore the 0x and just look at the code that comes afterwards. Cool. Okay. So far, so good. So it turns out that ASCII, that we were just talking about, lets us use hexadecimal codes too, as well as number codes. They kind of sit side by side and you can choose which one you want to use. So Lauren, thank you. Next slide's here. So here's that ASCII chart again. So it was blue before, now it's a kind of yellow color. But instead of just having those numerical codes, those 2 digits, we've got a code made up of numbers and letters. So let's decode a word like we did before with Lauren's name and the word empower, but this time we're going to do it with the new hex codes. So here's our code. Now, first off, remember I said we just need to ignore the 0x, so we're ignoring that. We'll do the first one together, and then I'll give you a couple of seconds just to have a bash at doing the other ones by looking at the screen and working out what you think it is. If you think you've got the answer, do pop it in the chat or just do it in your heads along with us. So, right, let's take the first one, 0x48. So I know I can ignore the 0x. So all I'm looking for is a 48. So I'm going to go across to the chart. I'm going to have a look at all the different numbers on the left-hand side, and I'm going to try and find 48. Bingo, there it is. In the middle, halfway down the third column, thanks Lauren circling it for us, we can see it starts with an H. So I'll just give you a few moments, see if you can work out what the rest of this word says. We know it begins with a capital H. Okay, well done. Yeah, absolutely. It spells hello. So well done if you spotted that, and an extra well done if you spotted that the final character is a sneaky 0 instead of a letter O. Cool. Okay, I think we're getting the hang of that. So let's move on to the next slide. Thank you. So ASCII is what most computers have used to make text for the last 50 years, but there's something seriously missing from those ASCII charts that we just looked at. And here's a clue. You can see these characters appearing on the screen. So have a think. What do you think might be missing from the ASCII standard that we've seen so far? Yeah, if you said non-English characters, well done. So it turns out that the ASCII standard is extremely English-centric. Now, most other languages have characters that just aren't included in ASCII. So any idea what percentage of the world's population has English as their first language? It's about 5%. If we broaden that to people who speak English on top of their first language, it's still only about 20% of the world's population. I mean, it's not a lot, is it? And if ASCII is the world standard and it can't accommodate non-English characters, there's kind of a bit of a problem there, right? So thankfully, someone has thought of it and has decided to fix this problem. And Lauren's going to tell us a bit more about that now. Thanks, Lauren.
Just turn it over. There we go. So this is where Unicode enters. So Unicode is the common global approach to character encoding. But sorry, it keeps skipping. Sorry. This quote really sums up why Unicode is important. So everyone in the world should be able to use language on phones and computers. That's great, right? It brings us right back to what all of this should be about, which is people. Not forcing people to use an unfamiliar language or alphabet with computers. It's hard enough to communicate with a person in an unfamiliar language, but computers, it's a different story. So the aim of Unicode, the aim I say, in the same way as the previous character encoding we've looked at, is that every character gets assigned a unique code. But for Unicode, that's for every alphabet, every single language, modern and ancient. So that's a lot of codes. So notice I said aim. Unicode isn't quite there yet. It's an ongoing project. So have a bit of a guess in your head at how many characters Unicode currently supports. It's quite a lot when you consider we were looking at 1 to 26 at the start. We're now on for Unicode 143,859. And that might seem like an awful lot, especially when we compare it, like I said, to the simple English alphabet encoding we looked at the very start. But Unicode is actually able to encode much more than that. So over 1 million different characters. To be precise, 1,114,112. Down into charts, and it covers all the different kinds of scripts. And as you can see here, like we would, as an English country, we would be in the European scripts, but as you can see, there's so many others. And if we look down near the bottom, then we see something interesting, which the box just about circles, and that is emojis. So I guess, that's why we're here, right? So about 15-20 minutes into our talk about emojis, I finally mentioned them. So Unicode became the standard universal way for computers to display language. In the late 2000s, when mobile phones really took off, emojis became a big part of communication between people. So Unicode, of course, got on board and started adding unique codes for emojis into their standards alongside all of the languages and scripts that we saw previously. So now emojis are just like letters in all those other languages, and there's a standard way for them to be used and shared between devices and people around the world. It's like emojis are general around the world. Everyone can share an emoji and know what it means, regardless of the language that you speak. So because of that, they're probably one of the most globally used set of characters. As I say, it's the same in every language. So I've seen an estimate that 92% of people that communicate on the internet use emojis, and over 1/3 of them do so every single day. So when you consider how many people there are who have devices, I think we're probably talking about in the billions of people who use emojis every day. So as I said, every character in Unicode gets a unique code, and we have over 1 million options for these unique codes. And each one of these unique codes is called a code point. So let's have a look at. So this is how they're written. In the same way as Jen described that hex numbers have the 0x in front of them to make it clear that it's hexadecimal, these ones here have a U0 in front to indicate that it's a Unicode code point, and then it will have at least 4 digits following. And you'll notice here on this last one, so XYZ, you can notice in the Z that it actually is a hexadecimal number, as in it has a number and a letter. Here's the code point for an emoji. Back to Jen now.
Well, thanks, Lauren. So let's have a look at some of the points in action. Lauren, if you can bring up the QR code and the link for me. Brilliant, thank you. So we mentioned earlier that if you've got a laptop or your smartphone with you, you are very welcome to try and code along with us while we're doing this, have a play with this website. If not, do not worry at all. We're going to do it together. We'll have it up on the screen too. And this session, I believe, has also been recorded, so you can always have a play around with it later, when you've got some time. So this is a website, this Unicode table website is recommended by the official Unicode website to explore the codes, the symbols, the emojis, the letters. It's quite easy to use, and it will become clear when you start playing around with it that it's quite easy. So Lauren, you're going to be my guinea pig. Can you bring up the next bit on the slide for me first? Brilliant. Okay, so we've got some Unicode codes, 3 of them there. And what we're going to try and do is search this website for those codes and see if we can work out what this message is. So Lauren, can you go in your browser to that website for me, please? Let's just wait for it to load up. Here we go. Okay, so I will tell you what to type in. In this search bar, this website allows us to search for, you can do it in 2 ways. You can either search for the codes or you can search for a description of the emoji that you're looking for. So to start off with, we're going to type in the code. So I know we can't see them on the screen anymore. I will read them out to you so that you know what you are searching for first. So first up is U plus, well done, 0049. Let's see what comes up and hit enter. Okay, I, easy enough. Okay, so the first one's not an emoji, it's just a letter I, that's good. So we'll make a note of that. Right, Lauren, let's search for the next one. So U plus, as always, at the beginning, yeah. 2764, please. What do we get? Heart. Cool. Okay. I heart. So far, so simple. Let's see what the final thing is. So U plus 1F for Freddie. 355. Pizza. Cool. Okay. So our message was I heart pizza. Let's go back to the slide and just check that we got it right. Cool, well done. Okay, and well done if you were doing that on your phone or your laptop too. I hope it worked well for you. Cool, so let's look at the next slide. Brill, so we're still on the website, and do you remember I mentioned earlier that you could either search for a code or you could start searching for the name of an emoji instead. So this time, rather than starting with a code and ending up with an emoji, we want to start with the emoji and we want to work out what the code is. So for each of these emojis, we're looking for that little code that says U plus something, something, something. We'll see if we can work out what it is. Cool, so snowman, sun, water. Right, let's go to that website again, Lauren. So first thing we're searching for in that search box, if you can delete that previous one, yeah, is snowman. So don't hit enter, but let's just see what options we're given. Okay, so we can see there's 3 different kinds of snowman in the Unicode database. Snowman, snowman without snow, and black snowman. So I think we're looking for snowman without snow. That looks to me like the one we want. Brill, so click on that one. And that gives us the code. Okay, so you can see there in purple down the bottom, U+26C4. So I will make a note of that when we go back to our slides. So cool. Right, Lauren, now we're going to search for sun. So start typing sun for me. Okay, don't hit enter yet. Right, okay, so gosh, there's quite a lot of suns. The first sun, I mean, that doesn't even look like a sun to me. That's like a little target or something. So I think the one we wanted was sun with face, right? So let's go click on sun with face. Got it? Brill. Okay, so U+1F31E is the code we want. And finally, we're searching for that little water drop. So let's start typing water. I think that would be a logical thing to search. Okay, no water. Right, okay, well, what else could it be called? Like drop? Okay, cool, droplet. Good, that looks like the one we want. Right down the bottom there, look. So if you click on droplet for me, brilliant. So U+1F4A7. Right, we've got our 3 codes. So Lauren, can you go back to the slide for me? And we will hit reveal. Brilliant, yeah, cool. So that's the ones we're looking for. So you can see then that we can use that website to either take the code and find the emoji, or take a description of an emoji and find the code from it. So one of the problems though, right, with having so many symbols and so many emojis, as we just saw, is that it can be really hard to find them. So, I mean, you'd think that the droplet would be able to be found underwater, but it wasn't. We had to search for drop. So you kind of have a bit of lateral thinking there. So that's one of the challenges with having so many symbols. Hard for computers, for people to work out which one they want. And also across different devices, they look different. So have you ever noticed on your Android phone, it might look different to how it looks on Facebook or on an iPhone or on some other device? They kind of look similar and you can get the, but they don't always look exactly the same. So let's just pause that thought there for a moment. Let's move on to our final exercise in this encoding and decoding that we're doing. So we're still on the same website. We've got a last couple of emojis to find. So Lauren, can you bring up the first bit for me? Thank you. Brilliant. Okay. So now we could go to the website and we could try and search for these emojis. But do you know what? I'm going to save us the trouble. I'm going to stop us right there. So although these 2 emojis do exist, I mean, we could go on WhatsApp on our phones right now and bring up the emoji dictionary and those 2 would both be there. They do exist. There isn't a unique code assigned to emojis like these. Lauren, if you just click the next button for me. Thank you. So the closest we can find on that website, the closest we would be able to find, is this code, which just shows the gender neutral generic yellow-skinned person waving. We're not getting a black man waving as we've got in that emoji